Welcome to Ask and Learn.
We have a block that's being pushed by a force that changes depending on the distance the block travels. And that's given as F is equal to 50 times S to the power of 1/2. We're also given the mass of this block, which is 20 kilograms. Its initial velocity, which is 6 meters per second. And we want to find the distance it travels when the velocity is 15 meters per second. And this velocity we'll call v2. And this block also experiences friction, and so we're given the coefficient of kinetic friction as 0.3. Now, since we're dealing with a force and we want to find the distance, we can use work because work is force times distance. But since we also have velocity, we have to take into account its kinetic energy because kinetic energy deals with movement of an object. So we can use the work energy principle, which is the initial kinetic energy plus the work being done is equal to the final kinetic energy. Now let's expand this a little bit. So the initial kinetic energy is 1/2 m v1 squared plus, and let's just leave the work alone for a second, is equal to the final kinetic energy, which is 1/2 m v2 squared. All right, now let's look at the work being done. The work here is a sum of the works involved in an object, so there can be more than one. So to figure out how many forces are involved, let's first draw a free body diagram of this block. So we know that force is going to the right, the force that varies, and since it experiences friction, the friction has to be in the opposite direction. Kinetic friction, and we have the weight of the block pushing straight down. Weight is just the mass times gravity, and which means we have a force in the opposite direction called the normal force. So we're interested in the forces in the x direction. And because of the free body diagram, we see that there are two forces involved, the force that varies and the force due to friction. So for work, we have this force that varies, and because it varies, we have to use an integral. This force ds from 0 to s, the distance we're looking for, minus the work being done by friction, and the minus sign because the work is being done in the opposite direction because the force is in the opposite direction. And that's given as coefficient of kinetic friction times the normal force Fn, and of course times S. So let's focus on this first part. We'll call this part 1, we'll call this 2. So looking at 1, let's take the integral. So again, let me write it out. So you have the integral from 0 to s, and then the force here is 50 s to the 1/2 ds. Taking the integral, we have 50 on the outside times 2/3 s 3/2. So you add a 1 to the top. 1/2 plus 1 is 3/2, and then you flip that and you get 2/3. And then the boundary is 0 to s, so the s stays the same. You can clean this up just a little bit. So we have 33.3 s to the power of 3/2. Now the second part, again, we had coefficient of kinetic friction times the normal force Fn times s, but we don't know the normal force. Going back to our free body diagram, the normal force is in the y direction, and the only force in the same direction is the weight of the object. So this becomes mu k times mass times gravity times distance traveled, s. Now we can plug this back into our previous equation over here. And at the same time, we can plug in some of the values that we know. So first, we plug in the work due to the force that varies, 33.3 s to the 3 halves, minus, then you have coefficient kinetic friction, 0.3 times mass, 20 kilograms, gravity, 9.8, and then times s, plus we still have the initial kinetic energy, 1/2 m, which is 20 times 6 squared, and this is equal to final kinetic energy, 1/2 times 20 times V2 is 15 squared. So we plug this one into the calculator, move it to the left side so it'll combine with this part. So then we still have 33.3 s to the power of 3 halves minus 58.8 times s minus 1890, and then all of this equal to 0. So this is a very complicated expression, and the only way to solve it nicely is by plugging it into a calculator. So we plug this into a graphing calculator and solving for s. We get s is equal to 20.57 meters.